going to do this. Yep, it's the d value, right? Plus 1. So instead of being at 0 here, it just moves up. It's your y shift, moving up and down. It takes the whole thing and moves it. Doesn't stretch it, right? It doesn't stay here and make it longer. That's your amplitude. Vertical stretch, horizontal stretch, if you want to think about it like that. This is just you take it and move it.
Because then the up one and then over the...
Leave this alone. This is very small and not a lot, okay? It's just asking you, label your values, okay? I guess I made it negative, don't I?
That looked really weird.
Okay, so notice when I ask for the values, CC. When I ask for the values, I'm just asking for the values. -2, 2, pi over 2. Positive. C is positive, right? When we ask about the x shift, we have to negate it, right? But the C itself is positive. This is positive. When I ask you for period, put it into the formula. When I ask you for amplitude, put A into the formula. -2, but our amplitude is just 2, right? Amplitude is a distance, so it has to be a positive value. Do you have to go home?
Yeah.
Okay, bye. See you later.
Bye.
Are you coming back? No, that's sad. Are you going to be all right?
Yeah.
Okay, bye.
Don't let the ghosts eat you on the way out.
Yeah,
I mean, the ghost was looking.
that's true.
That's true.
All right, so,
Bye, Maya.
Bye.
and when I ask for the D, the Y shift, you just give me what D is, because D, there's no formula for it. It's just literally D. Okay? Got it. All right, so let's erase this, or let's leave this alone, and I'm going to go over here. Is it still running? Can you tell?
My light is blinking.
Yeah.
Good.
I can see it.
Okay. Let me set the camera up so it's going to get me and a lot of Okay. It's got this little fish eye thing on it. I don't know why they did that, but whatever. Okay, so that was only 14 minutes. Holy cow. Oh, an hour. So now we're done with that. Let's look at this. Let's find out how to graph something. Actually. This is where I'm going to be mostly. No, don't confuse them. When I ask you for the period, give me the b value.
Well, yeah, but as you were explaining how to do
I
it,
was showing what it does to the graph. Who cares? When I ask for x shift, you need to know that that's your x shift. It's
right,
c negative.
but it's
negated.
not, wasn't that
No, do not graph
You
this
did that-
way. This is how you were taught before. Don't do it. Okay? This was to kind of show you what happens. Okay? Here's how you're going to graph it. You just plug it in, man. So what we plug in, 0, right? That's what we're doing when we graph, right? We're going to plug in 0 for x. Make a table if you want. When we plug in 0, we get 2 times 0. Plug in 0 for x. Look up here. Oh, let's wait for Emma. Let's wait for Emma. That wasn't like for Emma. It was trying to do this. Okay. 0.
We know you're trying.
This thing right here, right? We're plugging in 0. When we plug in 0 for x, what do we get for y? Well, we got to plug in 0 to find out. Plug in 0. 2 times 0 is 0. Plus pi over 2 is pi over 2, right?
Yeah.
Sine of pi over 2. Well, what is it? Let's look at our unit circle. What's sine of pi over 2? This is pi over 2. What's the coordinate? 0, 1.
1.
So what value is sine interested in? So we just found out this whole thing that we've done so far is equal to 1.
So 2 times 1 plus 1.
Is 3. When we plugged in 0, we got 3. 0, 3.
Okay, so when you do that, when you find like the radian, find which.
It's just sine of whatever the thing
Well,
is.
because I've been doing when I do it, I plug into the x, but I don't flip. When I just keep the radian as a radian, so I'm trying to times that by 2 and then I just.
Okay. Order of operations is important, but yeah, I know what you mean. So let's do some more examples, and I think it'll cement this for you. Let's plug in pi over 2. So when we plug in pi over 2 for x, what do we get for y? Well, let's plug it in. 2 times pi over 2 is pi. Pi plus pi over 2 is 3 pi over 2. Do you see how that is? It's 1.5 pi, which is 3 pi over 2. In slow-mo, 2 times pi over 2 is pi. We get that. We add pi over 2 to it. Got to get common denominators. Add it. 3 pi in the top, 2 in the bottom. 3 pi over 2. Did you see what I did there? Do you understand how to do that? Get common denominators. Okay, good. I like to skip the algebra if I can, but I understand that's not always possible. So this is sine of 3 pi over 2. What's sine of 3 pi over 2? 1 pi over 2, 2 pi over 2, 3 pi over 2. It's this guy. 0, negative 1, it's negative 1. So this whole thing is negative 1. Times 2 is negative 2. Plus 1 is negative 1. Don't mark your y-axis until you get your things, okay? Now I'm labeling my y-axis. Negative 1. There's your point. It's just an equation, guys. Just an equation.
Oh my god.
So it equals
Let's plug in pi. And we got negative 1, right? This keeps things straight, because if you don't do this, you might forget what you plugged in originally, right? I got 3 pi over 2. You might say, oh, when I plugged in 3 pi over 2, I got negative 1. Wrong. You plugged in this initially. It turned into 3 pi over 2 after you did all this. Make this chart. It helps. Let's plug in pi. So again, we're plugging in pi because this is our next one to plug in, right? Pi. 2 times pi is 2 pi. 2 pi plus pi over 2 is what we have now. 2 pi plus pi over 2 is 5 pi over 2. Do we understand why it's 5 pi over 2? Common denoms. That makes that a 4. 5 pi over 2. Yes? I need head nods from everyone.
yes,
Okay.
yes.
5 pi over 2. Sine of 5 pi over 2. 1, 2, 3, 4, 5 pi's over 2. Oh, look, we're back here. What's sine? It's 1, so this whole thing is 1. Ladies,
Sorry.
it's okay. We understand why it's 1, right? 1, 2, 3, 4, 5 pi's over 2.
Yeah.
Sine is interested in 1, or the y value, which is 1. 2 times 1 is 2, plus 1 is 3. When we plugged in pi, we got 3. So when we plug in pi here, we're going to get 3. It looks weird, but that's okay. It's because we did weird things to it. Look at all the weird things up here.
It all looks weird.
I know. It's okay. Don't worry about how it looks. Just do the algebra, and you'll be okay. Question?
Is there not to be a middle thing? Like, cause usually it'll like.
Plot your points and see what happens, okay? Because this makes things weird.
It's just not part of the
It's not one of our guys. It's in between these points,
Okay.
right? It's going to exist, but it's not one of our big ones that we're plugging in, okay? So when we draw it, it'll happen, right? This is why it's important to remember this is a wave and not just a V, right? A V. So 3 pi over 2. Let's plug that in now. 3 pi over 2 times 2 is 3 pi. Plus pi over 2. Common denoms. 6 pi over 2 equals 7 pi over 2. 7 pi over 2. Sine of 7 pi over 2. 1 pi over 2. 2 pi over 2. 3 pi over 2. 4 pi over 2. 5, 6, 7. Same thing as 3 pi over 2. Y value is? It's negative 1 times 2 is negative 2 plus 1 is negative 1. So when we plugged in 3 pi over 2, again, you might think 7 pi over 2, where's that, right? 3 pi over 2, we got negative 1. 3 pi over 2, negative 1. I bet 2 pi is going to end up at 3. But let's find out, because it could be different. It could be weird. We did weird things. Check it. Check it. Check it. Because we stretched our graph. You can tell, right? We have a stretch here of 2. So it's going to be 2 away from the origin. Although, we're not coming from the origin because our y-intercept was 1. 2 away from 1. 2 away from 1. And we move sine pi over 2 over, which means we moved it that way, which means it's going to start high like cosine. That's why. But do you need to know why? No. Plot your points and get done with it. If we have more time in the air, we totally go into the why. Okay? You're welcome. 2 pi. I know, why? Variable. I use that joke all the time. 2 pi. We plug in 2 pi. We get 2 times 2 pi, which is 4 pi, plus pi over 2. Common denoms means 8 pi over 2. Add them together, we get 9 pi over 2. Erase. Sine of 9 pi over 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's this guy, which is 1. Times 2 is 2, plus 1 is 3. It's a wave. It's a wave. Do we see?
Don't worry, I called him Calvin Coolidge today.
Calvin Coolidge is. Oh no, that's John C. Calhoun. Never mind.
Calvin Coolidge was an awful person.
John C. Calhoun looks like a
Sorry,
Calvin Minion.
John C. Calhoun, if I remember from the Civil War, was an awful person.
He was. He looks like one of the Marvel minions from
by Civil War, I mean post-Civil War, Reconstruction.
Reconstruction.
All right, so we got this. Now let's plug in negative values. You could, but if you're living on the wild side like I am, we know that there's going to be a pattern here. There's going to be this oscillation going on. As long as you keep the pattern straight, you're okay. Let's check it to be sure. Is negative pi going to get me 3? Let's find out. When we plug in negative pi, what do we get? 2 times negative pi is negative 2 pi. Plus pi over 2. 3 pi over 2. Do we see why?
Yes.
Common denoms. Negative 4 plus pi is negative 3. Right? 2 and 2. We get negative 3 pi over 2. Go to your unit circle. Negative means negative angle. 1 pi over 2, 2 pi's over 2, 3 pi's over 2 in the negative direction. We're here, sine, so we're looking at the y coordinate, 1. All that is just 1. Times 2 is 2, plus 1 is 3. Oh, look! Good. So our pattern is true. We can feel safe skipping all these other points. That's test-taking skills, okay? Make an educated prediction and do it. That's how you graph weird things. And it works for tangent, anything else, as long as you know that tangent is going to be the y over the x, right? We know that, yes? And that cotangent's the reciprocal. The x over the y. Do we understand that tangent is the y over the x? Good. Which means cotangent is the reciprocal, the x over the y.